Okay, I picked this problem because one, it had a triangular load, and I particularly picked it because it's got these weird springs on there. Um, kind of seems like a bad idea to hang a giant thing like that from springs, but anyway, it makes a nice statics problem. Okay, there are no X reactions in this problem. So when you first look at it, and you go, oh look, here's a free body diagram. There's only two unknowns. There is no X reaction. I thought we had to have three reactions. Well, there are no X forces. So basically, you can get rid of the X equation because there's no X forces. So really, it's two equations. Some Fy is 0, some moment equals 0, and two unknowns, TAB and TA and TB. The spring makes this problem, the springs make this problem a little complicated. Let's ignore that. Let's just do the statics first, because this is a statics class. Then we'll do the spring stuff later. Let's do the statics first. Here's the free body diagram, and again, notice there are no X forces, so we're not even going to use the X equation, and that works out. We can have two unknowns because we only have two equations, some Fy and some moments somewhere. I just decided to take moments about A, and just arbitrarily pick that, and you have going clockwise around A, that 900 times the distance of 2, and going counterclockwise around A, you got B times this distance of 6, and TB is just 2/6 or 1/3 of 900, which is 300 positive, so going up. Then I sum forces in the y direction, 900 going down. We just got that 300 going up, so oops, I made a mistake there. TA must be 600 going up, right? 300 plus 600 going up. Or how I really did this in my mind was, here's that 900. It happens to be the centroid. Oh, by the way, how I got the 900. 1/2 3 times 600 is 900. And it's located at 2/3 of the way from the pointy end of the triangle, so 2/3 of 3 meters is 2 meters. And 2 meters, coincidentally, happens to be 1/3 of the total length of 6 meters. And what I did in my head was I put the 900, and I knew it was 1/3. This is confusing. 2/3 of 3, which is 2, happens to be 1/3 of 6. This 1/3 and 2/3 really has nothing to do with the triangle. It's just where the resultant was. Anyway, if you have a 900 Newton load 1/3 over, the person on this side is going to carry 2/3 of it, right? If you're closer to the centroid, you carry more, and the person on the other side will carry 1/3. And so I knew the answer should be 600 and 300 newtons, and the 600 on the side closer to the load, and the 300 on the side farther. And that's how I knew this would be correct. Okay, now the spring stuff. We know that F equals K delta X, which means the amount the spring stretch, or delta X, equals F divided by the K. We have 900 newtons at, oh, I messed that up. It's 600 newtons at A, divided by 1, what is that? 1,000, so that's 0.6 meters. Right, 600 newtons divided by 1,000 is 0.6 meters. That's how much delta A deflects. 0.6 meters, that's a lot. That's like, I don't know, 2 feet, right? 2 feet, 0.6 meters. That's a lot. That's crazy. Anyway, then I got TB, which was 300 newtons, and it said the spring constant for B was what? 1.5 kilonewtons per meter, or 1,500 newtons per meter, and that came out to 0.2 meters. And so the left side, which I got wrong again, went down 0.6 meters. The right side went down 0.2 meters. So the total deflection here, the differential deflection, because we want to get the angle, is 0.6 minus 0.2, or 0.4 over 6. And the horizontal distance of that triangle, I'm just working with this triangle right here. The horizontal distance of that triangle was 6. And let me go plug that into the calculator and get the correct angle. I'll be right back. Okay, so I got 3.8 degrees. And there you go. Now, again, what makes this crazy is that the left side is deflecting 2 feet. That would be bad. You have a giant beam like that deflecting 2 feet. But anyway, that's neither here nor there. It's just a fun statics problem.